Today we're going to look at how we can do polynomial long division. It's very similar to how you would do regular long division. You know, when you would have something like 54 or 540 divided by 9, you would just look at how many times does 9 go into 54, and then multiply it, and then subtract, and then figure out the rest of the problem. But instead of doing just numbers, we're going to look at what happens if we take something like a quadratic or a quartic function and divide it by another polynomial. We're going to set up the polynomial long division just like we would regular division. We're going to take what we want to divide and put it inside here. And you want to make sure you're putting it in the standard form from the highest exponent down. If it skips any terms, make sure you leave a space in there for that term. But we went degree 2, 1, and then constant, so we didn't need to worry about that. Whatever you're dividing by, that's going to go outside here. The thing that's a little bit different is when we're doing polynomial long division, we only look at the first terms first. So we want to think about what would we multiply 4x by to make it become 24x squared. So I know 4 times 6 would make 24, and x times x would give me x squared. So I'm going to multiply 4x by 6x, and I'm going to put that up top there. And if I multiply that, that's going to get me my 24x squared. What's different is that when I put this number up here, I have to multiply it through every term that's out there. So right now I have this binomial. So when I go to do my next line, I'm going to take 6x times 4x, which is that 24x squared. We always want that first term to match. And then we're going to take 6x times that negative 3, which is negative 18x. And just like we subtract here, we're going to subtract this entire bottom row. Now when I do this, 24 minus 24x squared, that will eliminate that. But I have to remember now when I go here, I'm doing 6x minus negative 18. And if I subtract a negative, that's the same as adding. So I'm really going to do 6x plus 18x, which is going to give me 24x. And then I bring down whatever terms are left behind. Now I'm going to repeat this process one more time here. I'm going to ask myself 4x times what makes 24x. I know 4 times 6 is 24, and I don't need any more x's, so I'm going to add 6. And whatever, again, I put up here, I multiply through both terms out there. So 6 times 4x is 24x. 6 times negative 3 is negative 18. And again, I'm going to subtract that entire row. So 24x minus 24x, those will eliminate. Negative 24 minus negative 18 is the same as negative 24 plus 18, and that's negative 6. Once this term has a lesser degree than that, this becomes my remainder. So what we're going to do to finish up is we're going to say that this is our quotient, but then our remainder, we're going to take that minus 6, and we're going to divide it by the polynomial that was outside there. And so my answer would be 6x plus 6 minus that fraction of 6 over 4x minus 3. All right, we're going to do one more together, and then you're going to try a few on your own. So our next example, we're going to take a quartic function, degree 4, and we're going to divide it by that x squared function, that quadratic. So again, I'm going to take that first expression and put it underneath. I'm missing my constant, but I don't worry about that. I'll just leave the blank there. And then I have my quadratic out here. And again, we always start with just the first term. So x squared and 8x to the 4th are what I'm comparing. To make 1x squared become 8x to the 4th, I would need to multiply 1 by 8 to get the 8, and I would need to multiply x squared by x squared to get x to the 4th. So we're going to put 8x squared up top. 8x squared times x squared is 8x to the 4th. I always want that first term to match. And then I'm going to continue multiplying through. So 8x squared times 3x is going to give me 24x cubed. I'm going to line that up with my x cubed term. 8x squared times 5 is 40x squared. I'm going to line that up with my x squared term. And again, we're going to subtract that entire polynomial. So 8x to the fourth minus 8x to the fourth will eliminate. 19 minus 24 is negative 5x cubed. 24 minus 40 is negative 16x squared. And then we'll bring down that minus 19x. Okay, we're going to keep going here. I can keep going because I can multiply x squared by something to create negative 5x cubed. So to make x squared become negative 5x cubed, I would have to multiply by negative 5, and I need another x to get x cubed. So we're going to put minus 5x up there. So now I'm going to take this negative 5x and I'm going to multiply it through all three terms. So negative 5x times x squared gives me my negative 5x cubed. Again, I always want that first term to match. Negative 5x times 3x is negative 15x squared. And negative 5x times 5 is negative 25x. I'm going to subtract that entire bottom row. If I subtract those will eliminate. Negative 16 minus negative 15 is really the same as negative 16 plus 15, so I'm going to get negative 1x squared. Negative 19x minus negative 25x is the same as negative 19x plus 25x, so I'm going to get plus 6x. These degrees are still the same, so I can continue my polynomial long division. So to make x squared become negative x squared, I would need to multiply the x squared by negative 1. So I'm going to put a minus 1 up there. If I take negative 1 times that, that's going to give me negative x squared. Negative 1 times that is going to give me negative 3x. And negative 1 times that will give me a negative 5. I'm just going to stick it off the end there. Again, I'm going to subtract that entire bottom row. These should eliminate. 6x minus negative 3x is the same as 6x plus 3x. And then 0 minus negative 5 would be the same as plus 5. Once this degree is less than that degree, we're done. So since x to the first is a lower degree than x squared, this whole thing becomes my remainder. So we're going to add the 9x plus 5 divided by that quadratic as our remainder. Oops, I forgot my plus up. All right, so we just looked at two examples of polynomial long division. You're going to finish up numbers 3 through 8, and we're going to see how this connects to our rational functions that we're going to be starting working with in our next unit next week.